Hello there, taxidermists and gentle peeps. This is Neil Woodman from Digital Taxidermy, and I'm here with another in my series of modelling tips. So this time I want to talk about bridging and how you can use it. So one of the things that you can do, obviously, to span a gap is to use bridging. And if you've not used it before, you should try it. If you've not watched your printer, say, print a flat roof over a void, it's quite fascinating. It slows the print head right down and lays the filament in thin air. It drags it out like the back of a spider with a web, and then as the cooling fans cool it, it sort of shrinks and pulls tight. So you can use this thing to bridge gaps and fill in holes, and you can use it to enable you to do interesting things with models. So one of the things I tend to do is a thing called sacrificial bridging. And what this means is to put in a bridge so that it can be used instead of infill. And what do I mean by that? Well, if we take a look at this model that I have here, I've been working on this. This is like a bunker warehouse type thing for a new industrial range that we are working on. A lot of these buildings that I'm doing at the moment are hollow, completely hollow. They're done with a 1.6mm thick wall, so that's 3 to 4 perimeters depending. And what I'm doing now that I've got the shape and the model has been completely shelled, also got little lighting in here so you can stick LED lights in. Aha, that's pretty cool. Now that it's been shelled and I've got the detail in, we need to ensure that it's all printable. So how are we going to do this? Well, I'll take you through some of the processes. First of all, I'll talk about some of the bridging that I already have in operation here. So here on this vent in the front, we've got these series of bridges going across here. So I've chopped the bottom of these vent grills off so that they're perpendicular with the build plate. So you've got a run of 2 filament walls wide along the bottom there, and then it expands out. So it puts those first 2 down and it can build off of that. So what I can do to increase the reliability of that printing is I can put an additional wall in there, so we can do that now. If we just do this, and then we also split this like that, so we can see how these are working. So we can put a little wall in here like that, and like this. We just get rid of these, and then we can extrude it out. We'll go in 2 directions to be 0.6mm in each direction, so that makes it 1.2mm thick. And what that will do is just split the bridge in half. We need to increase that, don't we? That will just split the bridge in half, which means it's not covering such a huge distance. and we'll allow that to do that and that. We'll align that to this face. And extend. Just trim off those bits. And we've got ourselves a wall in the middle there. We'll just turn off that slice. And we can see that fits in there nicely like that. We've halved the length of that bridge, which makes it much more secure. Just pop a couple of fillets on there. There we go. So that's made that more reliable. The next bridges that I'm taking advantage of here are these, which are part of these vent grills, and they will print just fine. I've done it in several layers. I'll go through in another video how I do these and how they work and why they work and how effective they are. But for now, we'll just talk about the issues that this is presenting. So these will print maybe quite loose, and then the next layer will print, and because they're supported by all of these little bridges, that'll be nice and tight, and then by the time you get to the top, it's all perfect. Now here we have this platform, and this platform is lower than the rest of the wall, and so it will bridge from here to here, and that'll be fine. That'll work. The only problem is you've got these holes in the way, and it can't draw those holes in mid-air. So you would have to either put an edge around all of them and extrude it to the bottom of the model there, which we don't want to do. So what we're going to do here is just fill those holes in. Yeah, so we just filled those holes over, and now we'll find that that will bridge all the way across there. Now that will actually be quite a loose bridge because it's going quite a long way, and so it will draw these edges and then it will try and fill them all in, which will pull it all tight, do funny things. So the way we get around that is we add these ridges. So the first point it's going to hit is the bottom of these, and it will run these two bridges across here, and these are 3 to 4 layers deep. So by the time it is then doing this bit, these are already a solid structure, so it just does diagonals like this all the way across. Nice. But still we might want to give it a little bit more reliability, so we are going to add these as well. So you've got a couple of layers of these being put down, and then it will bridge across there. And then we've separated it up into little areas, which is going to make that nice and rigid, and it'll also give it a nice solid base so that this top skin can be ironed, and it'll be nice and steady, and you get a really good finish on the top surface. Just to finish those bits of bridges off, we add the chamfer details. So it's going to put down its first layer, which is not going to be that great, and that will use less perimeter lines. The next layer will be built on top of that, and then it'll all build up, and the chamfers just help to give it an incremental build platform. So that's one of the things that we do there. And then we're going to take a look at the rest of the inside of this. So I've already actually done these features. I'm just moving it down the rollback. scale. And so what I've done here, if you can see here, we have this little indent. I'm trying to look at the bottom layer here and make that print as well, so we're reducing the amount of moves on the tool head. So what I've actually done there is just extruded out this shape so we've got one smooth wall. Now here we have the edge of a bridge and we've got the roof there. So looking at that, so this has just done the same over here, and looking at these bits, I want to do something about that. So we have now filled in this bit. So there we go. We've filled in this bit so that it has a little bit more stability by the time it gets to the top. We've added a little chamfer there, so it's got an incremental build, and it's got a nice defined edge there. We've mirrored that across to here, so we've done the same thing, and we've added the chamfer. The next thing is I have split up this run. So again, right at the end of the bridge, we have these beams that we've put in, and it's much like you would build a house. So these beams go across and they support the roof. It also, if you look in your slicer at the way that the slicer handles bridging will be done in straight lines, and then where you've got areas like this, it will go diagonal across it. So you want to try and break up those points so that it has a much better path to it. It really helps to tighten up those top layers when you've got very little supporting it. And again, we just filled it off with the chamfer, so it will lay those first ones down, and it will build up from there and make it nice and strong. So the next step is we see these alcoves. Now these alcoves, we've got this chamfer here, and we've got this flat platform here. Now that would possibly come out quite happily, but what we're going to do is just try and increase the chance of success. So we're going to make the inside a lot neater here. So we put ourselves a little box in there, and we're just doing the same over here. So if I just select this and this, so you'll be able to adapt this to whatever program you are using. There's lots of different ways to do it. You can do it by feel, you can do it by eye, you can do it by dimensions. It's entirely up to you. So just try it out. If you have models and you look on the inside or you look on the underside of a big overhang, and you find it's all loose and drooping down and stuff like that, maybe you need to put in some of these bridging techniques to just secure that and make it a lot more stable. So we're just extruding that down 0.6 millimeters. So that's going to be effectively 3 layer height if you're printing at 0.2 millimeter layer heights. And we are then going to chamfer that. Put the little chamfers in. Again, just to give us a incremental build platform. Can be a bit fiddly. There we go. So that has So that there will have a good effect on that. What's happening there? What is that doing there? So because this is a curved wall there, we are having a little issue with this sticking out from the wall. So what we might do with this chamfer is just change the depth of it, and we'll take that to do it. So what I will do though is to just trim that off, and so just get it so we can see, and in this case all we're going to do is put a sketch on there, and we will silhouette this. So put sketch on, I'm going to silhouette that, project this one to camera. All sorts of fiddly things to make this stuff happen, but it is totally worth the effort in the end. So small things making a big difference is definitely the theme of this video. So we go back to the sketch that we are in, convert this teeny tiny little bits. So we've got that one, and we have this one, and then we can just cut those out. There we go. Tidies up that edge, makes that nice and neat. So that has made that good. The next thing we have is these overhangs here. So with these overhangs, we are, because it's internal, it doesn't matter about the softening of this detail. So all we're going to do is put in a chamfer that is going to forget how big that all is. So that's a 1.2mm chamfer, and the same over here. These are mirrored, so they should be the same. So what is going on here? So we will chamfer both of those. For some reason, that one is extruded further in than that one. So I'll go back and fix that in a little bit. I won't do that right now, but I will go back and fix that. And then the same over here. We will take that one and we'll put a chamfer under there. Okay, so because that's 45 degrees, that will pick up on that, and that's going to pick up on that, and once I've moved that back in, that will pick up on that. So we fixed up there, that's going to be okay. We could have that extrude further down and then put in a central beam across there as well. I think with the case of this one, I will test print it and see if it needs it, because it's a very small span. I don't know if it necessarily will, so we should be okay. Now here we've got a really big overhang, and there's a few choices. I mean, we could just extrude that all the way down to the bottom, but of course what you're going to get is a lot of infill. It's supporting this balcony detail. I've still got to do a doorway and such on there, and rather than bring that all the way down and use up all that filament in support, what I think I am going to do is put a bracing wall between here, and the same on here and here, and then run a bridge across this back piece. So I'll just show you how I would go about that. So we'll take that, put that in there, that in there. Take that to there. And then back up to there. So we just put that in fairly rough at the moment, and what we're going to do is just mate these various pieces together. So we're going to apply relations that will then place the lines on those surfaces like that. And line that up with here. And this is always the sort of time where everything goes horribly wrong, but we will give it a go and see. So then we'll extrude that out, and we will just go up to that surface like that. Okay, so we've now got this bracket here. So that will then provide support for the back edge of this on the bridging. Just add that chamfer in there. Okay, so that's nice like that. Okay, we're pretty happy with that. So we're going to mirror that across. So take that, and we'll take the chamfer, and we'll mirror it about the center line, because we might as well do that rather than draw it all again. No. Can't take the chamfer as well. Interesting. So for whatever reason, it is not letting me. Yeah. Okay. So we will have to redraw it. So that's nice and easy. What we will do, just might as well get rid of the chamfer then, and we'll take the sketch, draw it on there. We'll convert that Click on there, start a sketch, convert that to there, click on this, convert that, lovely, lovely, trim, and then we will extrude to up to surface, and there we go. So we've got the supports. So you'll see as we go in, not everything always goes to plan the first time. Sometimes you have to work your way around a problem. It's your ability to solve problems which will earn you your money. Didn't go in. So here we go. So this is all down to the details at this point. This is how we increase the repeatability of models. This is how we consider the tool pathing and everything, and just how all the little features have an impact on what it is you are trying to achieve. So again, we will have here some more bridging just to give the back a little bit of extra support and sort out the pathing for this big overhang here. So we will extrude, so 0.6 millimeters, so 3 layers, chamfer that in. Okay, and same on this side. So there we go, and we've got ourselves a nice little grid in there. With this particular one, I am going to add another little piece across here, which will be another 2.4 millimeters thick, and we will put that right on the center line. So I'm going to select midpoint, and we will add a relation to the center line there. So then we can extrude that down, and this one is just going to be 0.4 millimeters. So we've now broken that into two. We'll just edit this one so that it becomes 0.8 instead. Excellent. So that is now looking much better, because we added an extra 0.2 on there. We will also turn that to 0.8 chamfer so it doesn't have that little bit sticking out. Cool, so that's looking quite good now. If we see, so that's got chamfer underneath it, that's got chamfer underneath it. All these have got supporting beams underneath them, which will give them a nice strong place to lay down the filament. All of our overhangs have some kind of a support. So yeah, that's looking quite ideal. I mean, if you've got a few minutes, I can quickly go around and sew what I will then do is take a 0.8mm fillet. So we talk about chamfers, bevels and fillets in another video. Feel free to check that out, and that will go into a lot more information about how that affects your toolpath and why you might want to use them for various things. So because I am trying to make these with thin walls to print smoothly and with as minimum filament as possible, one of the things I want to do on the inside is to make the toolpath nice and smooth and easy. It reduces the jerking motions, it decreases the print time, and it all in all will end up with a much better print. So any vertical lines will get a little 0.8mm fillet, which will make a difference. Makes a big difference in the long run, and just generally makes your print smoother, makes the print head travel smoother, less jerky motions, you get less noise from your printer, less vibration, all of those good things. So we'll just do that round every internal vertical line, because it really doesn't matter on the inside. Because we've done a 1.6mm wall as opposed to a, doesn't like those ones, because we've done a 1.6mm wall as opposed to a 1.2mm wall, it means that we can do these on any of these corners and it won't negatively impact the tool pathing. So you won't end up with walls that are too thin that you don't get at least 3 perimeters. If it was only 1.2mm, you would get certain issues with the tool pathing, whereby some of the walls would be too thin. Doesn't like one of them. Why doesn't that like one of them? There you go. So we might have to check that out and see why that is. Let's just see what happens if we do that. This might play up. We'll see. It could just be it's stopped displaying them because there's too much information there. So we'll carry on selecting and make sure that we've got all of those vertical lines. Lovely, lovely, lovely. Incidentally, I'm using a 3D connection space mouse in my left hand, which is why I'm able to do all this moving very quickly. They are an amazing piece of kit if you can get hold of one, if you want to spend the money on one. They are fairly pricey, but they really are the business for maneuvering in a 3D environment. You can use them to get around. Basically, it's a 6-axis mouse, so any motion that you put on the mouse itself is replicated in the 3D space. So it's like manipulating the model with your hand. they're absolutely fantastic pieces of kit, and I wholeheartedly recommend that you check them out. Again, it's not something that a casual user might want, however, it's maybe something that people that are doing this more full-time would want to explore. That's going to be too thin for the 0.8 ones, so we'll just get rid of them, and we will see how many of these are going to fail, shall we? So let's see. So yeah, it doesn't like all of those features, but that will chug away, and then we'll see which ones don't get done, and we'll work out what we have to do, if anything. So yeah, a 3D mouse will greatly speed up your workflow and enable you to move around a lot easier in 3D space. It means you don't have to use your mouse and hotkeys, which means that your mouse can constantly be busy doing other things. So at the moment I can move around the item and still click on things at the same time. If you're just using your mouse, you may be in a position whereby moving around in space causes you to click on stuff, which can ruin some of the operations that you're trying to perform. While that's processing that, we can have a little look. I'll show you. So these are the 3D Connection Space Mouse products, and they really are fantastic. So this little knob here, you can twist, turn, rotate, push, pull, and that does all of the functions of movement: pan, tilt, yaw, twist, and zoom. So yeah, they're really fantastic things. As I say, they are quite pricey, but personally, if mine ever broke, I would have to buy one tomorrow. I couldn't be without it. It's now that essential. Okay, so there's some fillets here that didn't work, which I will go back and find out why. I will actually drop down now to 0.6 and go and pick up on the last of those. So yeah, dropping down to 0.6 is going to solve a fair few of these, and also we can then pick up on these ones. I have to come back and get this one. Yeah, here a bit. Which ones haven't been gutted? That has. So we can get these ones as well now. Again, this is just a nice touch at this point. Remember, all of these are it's just increasing the neatness of flow of the printhead. So small details that mean a lot. So you may think it's quite hard to make a model, put the visual detail on everything. Quite often it is the things that you can't see that really make a model. So this is all part of the process. However, I am aware that this is now taking a while, and I don't want to bore you entirely. I mean, boring you a bit is okay, but I don't want to bore you entirely with all of this. So there's a reason I didn't get that. We can. Yeah, it's not going to do that one. So we'll get rid of that one from the list. Okay, so we've got that, and then some of the details you won't be able to get quite as well as you wanted, but again, it's worth just persevering and trying to get those. It really doesn't like doing those ones. So I'll look into those when you guys aren't here. And then for the final little piece, what I will do from here before I go to test print it, which will be the final sort of step, is, let's let this come back. So I'm going to take into account what the first layer is going to be like, and I'm going to place an internal brim around the inside of the model, and then I will give it a slice in Cura, just double check it, make sure everything looks okay, and then send it across for a test print. And once the test print comes out okay, then that will be ready to go. If I find that, for example, this piece or any unexpected bits crop up from the test print, I'll come back in and make the modifications, check it in Cura. If needed, I will do another test print. If I don't, then we'll be able to verify that just by doing a slice, making sure I've got rid of the trouble spot. But anyway, I hope you've learned something from that. That is how you can use bridging to avoid using supports in many circumstances. Like I say, we'll go have another video at some point where we talk about this type of bridging and other ways to use it. But I hope that's been useful. I've been Neil, and we'll see you around another time. In the meantime, check out www.digitaltaxidermy.co.uk. We've got a whole bunch of new models coming out. There's always something on the go here. And the Digital Taxidermy Buyers Club is a great way for you to get involved, get a whole bunch of models for only £10 a month, plus the opportunity to buy past bundles for a massively discounted price as well. So we hope to see you there. I hope this has been useful. If you have any other videos you'd like me to make, any topics you want me to cover, mention them in the comments. Give this a like, subscribe if you want to. Don't forget to ring the bell, and I'll see you again with another modelling tips. See you later. Bye bye now.
Like the video, follow me around, press the bell, it makes no sound. Like the video, press subscribe, I don't know why I am.